Thanks for your time, Rahul and Sameer, and congratulations for project Har Indian Ka Moonshot. Could you please explain what is Har Indian Ka Moonshot and how is Team Indus taking this forward?
So Team Indus is a startup that we put together a little over 5 years ago. We're competing for this international prize called as Google Lunar X Prize. We're building a spacecraft that is capable of landing and then deploying a rover which is capable of moving 500 meters on the surface. It's an ambitious program. When we started off, we didn't really know how far we're going to go, but I think we made sufficient progress. We have validated our progress with an international jury, with ISRO, and today we are announcing the fact that ISRO has agreed to give us a launch vehicle to send our spacecraft towards the moon. So that's the genesis of the program. We've grown to about 100 people, but that still is too few people in order to accomplish a task as complex as putting together a spacecraft for the moon. Har Indian Ka Moonshot is our campaign. It is our mechanism that we're going to ask, that allows a lot of people, a lot of Indians to call this mission their own and to be part of it. So one of the initiatives that we've launched a few months ago is where we're asking students to design an experiment, and the best experiment actually flies on board our spacecraft and goes to.
Sure. Could you please explain what is placed next to you and how is it associated to the entire project?
Correct. So this is the reason why we are hiring a rocket. We're building a spacecraft, which is this 10 kg rover. It's a micro rover class category rover. Has to be taken all the way to the moon, and it should be gently put down on the surface of the moon. So this is a 4-wheeled rover, all completely solar powered, independent DC motors. It has about 6 cameras on board. It has about a 30-watt solar panel on board. So this is what is called as a exploratory rover. Because the terrain is unknown, this is got a completely passive self-leveling mechanism. So the locomotion is unique the way this has been designed, and it is when on the moon this will be able to climb 30 degrees of slopes, reverse, automatically detect and avoid hazards, and so on and so forth.
We heard that you have a very interesting story of participating in this contest, and by far you have associated a lot of people who are non-space engineers. Please share on how you started off and how are you dealing with the non-space engineers on a space-oriented project.
Engineering is engineering. Space is one of the applications of engineering. So we today, out of 100% team, close to I would say about half of them are from an aerospace background. The remaining half are from other engineering disciplines. Building a spacecraft is a very complex task. It requires a dozen engineering disciplines to come in. So structures, mechanisms, control systems, communication, power, so on and so forth. So we believe we have the best of the breed when it comes to the talent that works with us. I think it's the culture of the organization that keeps all of them together, and despite the small size, we have been able to make great progress when it comes to technology.
And how did it all start, Sameer?
It started on a day when we actually heard the news that there was a competition called the Google Lunar X Prize. The competition says that you have to land a robotic craft on the surface of the moon, make it move for 500 meters, and send back high definition imagery proving that you've landed and actually been there. So we were all relaxed and sitting together, and we suddenly went through this news. What struck us as very strange was that there was no Indian team in this particular competition. And we asked ourselves, why is this so? And we asked the organizers at Google, we called them up, and we found out that, there's no team. So we took a quick decision. It was more like an instinctive decision that if at all we break this into a system engineering problem, rather than looking at in a holistic, as a mammoth task to achieve, this is a doable task. However, of course, at that moment we were more about passionate. We were very passionate to do it, as well as more in a patriotic fervor. So we decided, yes, we want to do it, and we applied with Google, who gave us another 10 days, 15 days more to fill up the application, and we were allowed to take part out of the 32 teams.
Sure. And how did you all start? I mean, you were not doing such stuff prior to Team Indus came together, and how did it all start? How did you sort of think of creating something as cool as this?
So it was more to do with the DNA of all of us together. Rahul has been a serial entrepreneur, and I am ex-Indian Air Force. Air Force teaches you a lot, takes you to some extremes, exposes you to a lot of environment where high technology is involved.
Right.
And that is where we all got together, put our minds together, and we realized that if at all there is an opportunity, the opportunity is now. Here is something which is definitely something worth a try, and this is where we said that even if extreme technologies are involved, we can definitely take a crack at that. So it was, as I said, it's more in the DNA of the team, of course supported by some amount of to an extent of our technical backgrounds, but DNA of the team and patriotism, that's what we bank on when we actually would like to finish this mission to its end.
Sure. You'd like to launch the project somewhere after 27th of December is what we heard during the press conference. Could you please explain the timelines and how are we placed today?
So what we are doing right now is a very fast-track project development. The aim being that now that we know that we have a contract with the Indian Space Research Organization for a PSLV XL, which is going to take us through the Earth's atmosphere and launch us into outer space. Naturally, we have certain very stringent timelines, which having said that, had we had some more time available, would have been handled in a different manner. But because this whole program, the way we have done it on a fast track, so it is a definitely achievable timeline. What we have been doing in 2015 and 16 is more of prototyping, getting it to the design and development stage, where we have been able to freeze the design, validate it, get it validated, and test it to a great extent. Now we are at that juncture where we start to make actually the flight model, which is actually going to go there. Plus we'll also make a spare.
Right.
These are some timelines which are more dependent on what kind of equipment we are integrating all together, and some vendors who are going to supply us, basis our orders. So these will be dictated by that. So I see that the next 1 year is something we are going to put it all together and hand it over to the Indian Space Research Organization for placement on the Polar Satellite Launch Vehicle. End of December is a period where we see that all conditions for us technically meet, where if we launch the lunar lander, it is going to go towards the lunar surface in a planned maneuver which we envisage, and within those conditions we have nearly a 10% success rate probability. So that is where that launch rate, what you actually asked, is very critical. We have a launch window, a certain time period starting from the end of December next year, and this goes up till about end of January, where this 20-minute launch window is very critical for us. It's more to dictate with the mission completion, the way we would ideally want to launch and land on the surface of the moon.
So what happens when the rover is launched? What is the process when you shoot the launch from here, from Earth? What happens post that?
So you will be launched from a vehicle which has to go out of the Earth's gravitational pull in something which we call an escape velocity maneuver. So this vehicle is provided by the Indian Space Research Organization. So our lunar lander, on which our lunar rover is going to sit, is going to be part of the payload for this PSLV XL platform. This will be launched. It will take us outside the gravitational pull of the Earth, and thereafter release the lunar lander to do a couple of maneuvers, 3 different maneuvers around the Earth, so that the velocity, as well as we call it, an orbital, pull around the Earth, from where it is going to increase its velocity as well as the distance of separation between the Earth and the platform. To that an extent, where in the final elliptical orbit, it is going to be very close to the lunar gravitational pull, where we slow down and capture that particular orbit around the surface of the moon. Thereafter, we will continue to slow down to that an extent where we will finally reach a spot where we have to carry out the landing and descent maneuver. This is a very critical maneuver, about 15 odd minutes it's going to take us. From a very high velocity, we come down to near zero velocity and soft land on the surface of the moon. And once the lunar lander has deployed on the surface of the moon, it will be deploying its rover, which is the piece what you see here, and this is going to move on the surface of the moon in the way we have planned, in the area which we envisage it to operate it, and carry out all the scientific achievements as part of this Google Lunar X Prize.
Sure. And then it is likely to come back?
No, it's not going to come back. It's a one-way mission we have planned.
Okay.
However, what is going to lay down is a foundation of a lot of technologies where we will be validating capabilities to go into deep space. So in the times to come, this is a very critical technology which a company like us is going to possess, as well as contribute towards the overall aerospace ecosystem within India. I'm sure a lot of us, especially us Indians, will benefit because a lot of other countries have already possessed this capability and technology in the private domain.
Sure. Team Indus is a startup. Do you face the startup challenges, Rahul, that the other startups in India are facing, despite the despite the fact that you are doing work which is way too different from others?
I think we continue to face the same challenges that other startups face. It's just that the magnitude is amplified, and so that's the negative side of what we're trying to do. But the positive side is that we are, what we're doing is so audacious that anybody that we approach for any kind of support has always been forthcoming, and I can almost say in 19 out of 20 meetings that we have had till date, every 19 out of 20 meetings has resulted in something positive for us. So it's that high a percentage of conversion when it comes to positive outcomes. So standard challenges, yes, maybe slightly amplified, but we also have positives that help us keep it going.
Okay. One very important part of startup setup is the funding bit, and your funding has to be huge for this kind of a project. How are you handling that, and how have you handled that by far?
We have various different strategies. One strategy for every startup is to be able to dilute a certain amount of equity. That's something that we've done very successfully. The kind of people who have signed up to invest in the company are the thought leaders of India, who are really building for the India of the future. The second strategy that we have in place is to be able to sell payload commercially. So we have excess capacity on the spacecraft, and we'll be selling some of that payload commercially. The third bucket comprises of we're looking for sponsors, we're looking for people who want to be part of this mission, to be able to participate in it. So that's something that we are building on. 3 strategies. First one of them has played itself out. The second one is in progress right now. We should be able to make an announcement in January. And the third one again launches early next year.
Sure. You call it this project as Har Indian Ka Moonshot, aptly named, and you are actually living up to the patriotic spirit that you started up with. But how is Har Indian included, and how is Har Indian contributing to this project?
That's something that we will be announcing very, very soon. So think of this as a pre-announcement or a trailer to a series of programs that we're going to run, which will allow different kinds of people who are interested in being part of this to be part of it. The one program that we've already launched is called as Lab to Moon, which challenges bright kids, 15 to 25-year-olds, to design an experiment, and one of those experiments will fly on board our spacecraft to the moon. So a great way to encourage talent, which is looking to do disruptive stuff, looking to build new things. It's a great problem statement to give to them. We received 3,000 entries, which is very, very interesting. And now we've down selected it to about 25 entries. So that's where we are.
Sure. So after this project is launched, what is Team Indus up to?
I think we'll have a huge amount of capability in-house under one roof when it comes to systems design and program management. I think those are the 2 areas which have been sort of neglected in India. I mean, that's something that we don't do too well. So we're fortunate that we managed to put together a team. We managed to have a a program that motivates everybody to put in their best. So we'll have the kind of capacity and capability that is relatively rare in India and across the world. We believe we can leverage that to develop and deliver products and services for the aerospace industry.
Sure. Thank you so much for your time, Rahul and Sameer, and to everyone. Congratulations to everyone with Team Indus. This truly is a great initiative, and we look forward to the success of the project. Thank you so much.
Thank you.
Thank you.